Hi, welcome back to my channel, How to Pass. In this chemistry video, we are going to be looking at patterns of behaviour and we'll be exploring the reactivity series and displacement reactions. If you are new to this channel, please subscribe as it really supports me, and share this to all your friends as this may be really helpful for them too. In this video, we'll be covering the following topics: the reactivity series, reactions of metals, and displacement reactions. This is the reactivity series. It lists the metals in order of their reactivity towards other substances. This list is very important and I will encourage. You can see gold is the most unreactive metal and potassium is the most reactive. In the reactivity series, you may see carbon and hydrogen, non-metals, as they show you the position. The reactivity series can also help us decipher which metals are easy to extract from their ores. For example, the higher the metals are up the reactivity series, the harder they are to extract. For example, gold is highly unreactive, so it is found in the earth as an element and not in a compound, so it can be easily extracted. That is why it's on the bottom of the reactivity series, as it is really unreactive. But metals such as potassium react very quickly with the air and other metals, so they are always in a compound. You would have to use processes such as electrolysis, which are very energy consuming and consequently expensive. Scientists have made the reactivity series using many experiments reacting a metal with either air, water, acid or other metals. I will show you what happens when the metals react with all these other reactants and what the products turn out to be. The first reaction is with metals and air. In this case, we are not talking about air as the mixture, but more specifically oxygen in the air, as most other elements are very unreactive. When you see metal discoloring or tarnishing after being left outside, this is a reaction called oxidation, not oxidization as many people mistake it as. This causes a dull layer of metal oxide on the surface of the metal. The more reactive the metal, the more vigorous the reaction is when it is burnt in oxygen or air. The reaction between a metal and oxygen is metal plus oxygen goes to form metal oxide. For example, zinc plus oxygen goes to form zinc oxide. The second reaction that you will need to know is metals with water. Metals that react with water react very vigorously. These include calcium, magnesium, sodium, lithium, and potassium. When potassium reacts with water, it floats, fizzes, and produces a lilac flame. Lithium floats and fizzes. Sodium floats and fizzes and melts. Magnesium reacts slowly, and calcium floats and fizzes. This makes the reaction of water. Metal plus water goes to form metal hydroxide plus hydrogen. For example, sodium plus water goes to form sodium hydroxide plus hydrogen. The last reaction will be metals with acid. More metals react with acid than water, such as zinc, iron, and magnesium. However, copper does not react. Remember, it is very dangerous to use elements such as sodium, potassium, and lithium, as they react violently with acid and could harm the person conducting the experiment. This makes the reaction of acid, metal plus acid, goes from metal salt plus hydrogen. For example, iron plus hydrochloric acid goes to form iron chloride plus hydrogen. You could also use sulfuric acid, forming a sulfate, and nitric acid, forming a nitrate. You could test for hydrogen by holding a lit splint over the area of the reaction, and if there is a squeaky pop, there is hydrogen produced. So how do you determine which metal is more reactive using an acid? Put the metal into a test tube with the acid and record the temperature change. If there is a higher change with one element than another, that one is more reactive. Let's move on to displacement reactions. These are very closely linked to the reactivity of elements. This is because these are reactions when a more reactive metal kicks out a less reactive metal in a compound. A key reaction is the thermite reaction, where aluminium and iron oxide make a very exothermic reaction, which means heat is given off. The aluminium takes the iron's place in the compound, forming aluminium oxide and iron. With the word equation, aluminium plus iron oxide goes to form aluminium oxide plus iron. This type of reaction is very effective when trying to extract elements from their ores. For example, carbon is used to extract elements below carbon in the reactivity series from their natural compounds. This is called carbon reduction. This is the end of the video. Thank you for watching, and a major thank for getting this channel to 100 subscribers. Now let's try and get this to 500 as our next goal, so please like, share and subscribe. If you have any questions, put them in the comment box below, and I'll see you in the next video. Goodbye.